Hello everyone, welcome to the course Computer Networks. This is Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about data link layer. This is the second layer in OSI reference model. It is the second layer of the OSI reference model from the bottom. It is the from the bottom second layer of the OSI reference model. The first layer is what? This is the physical layer. This is the first layer in OSI reference model. In previous sessions, already we discussed about what is physical layer, what are the different types of transmission mediums like wired, wireless transmission mediums. Those all comes under the physical layer. And the next topic is the data link layer. This is the second layer of the OSI reference model that we are going to discuss in today's topic. And let us see the overview of the today's session. First, we have to discuss about what is the introduction about the data link layer. What is exactly data link layer, where exactly we are using, how the data is transmitted through the data link layer. Those all we will discuss in today's topic. And next one is the what are the different types of the data link layer. And next we have to discuss the what are the design issues of the data link layer. These all topics we are going to discussing in today's session. First, let us see the introduction. So, the data link layer is the second layer of the OSI reference model from the bottom. See, in OSI reference model total how many layers are there? Total 7 layers, right? These are the 7 layers. What are the 7 layers? Like application layer, presentation layer, session layer, transport layer, network layer, data link layer and physical layer. From the bottom, this is the second layer. The first layer is the physical layer. So, this is the main responsible for the node to node delivery. That means device to device. From one node to another node, we have to send the data. The node to node delivery mainly comes under the data link layer. And the major role of these data link layer is the error-free transmission. Whenever the data is transferred from the network layer, see in this picture, whatever data is coming from the network layer, the data in the form of the packets. Those packets are going to be converted into the frames using the data link layer. So, whenever the packets are converted into the frame, that frames are going to be error-free. Means there is no errors, error-free transmission of the information. That is the major role of the data link layer. So, it is talking about it divides the packets into the frames. At the same time, it adds the header. It contains what header is contained? It contains the address of the source and destination, and also it provides the error control. Means it is having the address. Means which address we have to send the data. Means sender address is there, at the same time receiver address is there using the MAC, that is media access controller address, means node to node delivery, right? That's why we are going to use the MAC address. That is the address and control. Error control means whatever errors are coming, means whenever the data is transmitting from the layer to layer, the errors are coming, right? Those can be overcome using the data link layer. That is the error free transmission. And coming to the data link layer, it is also responsible for the encoding. If you want to encode the data, we can encode, and decoding also comes under data link layer. And we can also use the organizing the outgoing and incoming data. That is also responsibility of the data link layer. And coming to this data link layer is considered as the most complex layer because it is the most complex layer of the OSI reference model because it hides the all underlying complexities of the hardware from the above other layers. That's why it is called as the most complex layer in OSI reference model. This is about the introduction of the OSI reference model in the data link layer. And next one is what are the sub layers of the data link layer? What are the different types of the data link layer? That is LLC and MAC. LLC is nothing but logical link control, and next one is the media access control. These are the two types of the sub layers we are using in data link layer. What is the main responsibility of the LLC layer is? It is talking about the multiplexing. What is multiplexing here? It allows the multiple data streams. All data streams that are going to be transmitted simultaneously over a single physical link. Whatever the links are coming, different links, those data streams are going to be transferred using a single physical link. That is called as the multiplexing. This one, and at the same time, next one is the flow of data. How the data is going to be flow from node to node. That is also comes under the logical link layer. And also it is talking about the error control. That is error. If any errors are there, whenever the data is going to be sending and receiving, that is also comes under the logical link control. See in this picture here, the network layer and network layer, this is the physical layer. In between, this is the data link layer. That is DLL, right? So, this data link layer is having LLC and MAC. LLC is nothing but logical link control. It is supports the error control, means error detection after error correction. Those two comes under error control. And next, data flow control. How the data is going to be flowing. At the same time, framing. These three comes under the logical ring control layer. At the same time, coming to the MAC layer. What is MAC layer here? It is the sub-layer. It manages the devices interaction. How the devices are going to be interacted each other. At the same time, the responsible of the addressing of the frames. We have to give the address of the particular frame and also controls the physical media access. See in this picture, MAC layer, what is this going to be substituted? So, dynamic channel allocation. See, here is the sender, right? This is the sender, this is the receiver. In between, for transferring the data from sender to the receiver, this is the channel. Whenever we are allocating a particular channel, how the exact data is sending through this particular channel means, if suppose here number of sources are there. So, these all are using say this particular channel only. Through particular which device I have to allocate this particular channel. That is comes under the dynamic allocation. At the same time, the physical and MAC addressing means which device I have to send the data using the MAC address only. And quality of service. These all comes under the MAC layer, that is media access layer. So, this data link layer in the MAC sublayer, that is receives the information in the form of the packets and from the network layer. So, whatever data is coming from the network layer, that is in the form of packets. So, whatever packets are there, that is going to, these packets are divided into the frames. These are divided into the frame. Those are going to be sent to the physical layer. That is sent to the physical layer in the form of bit by bit. That is to the physical layer. In the form of bits, we are going to send the data to the physical layer. That is about the MAC sublayer. These are the two types of layers in data link layer. And next topic is the what are the design issues of the data link layer. What are the main design issues of the data link layer is the first one is the framing, and second one is the addressing, and third one is the error control, and next is the flow control, and finally access control. These are the different design issues of the data link layer. See, first let us see about the framing. What is framing here? Framing is nothing but it is a function. It is a function. Mainly it is talking about the whatever data is coming from the network layer, that is in the form of frames, right? The packet is received from the network layer, that is known as the frame in the data link layer. The packet, whatever is coming from the network layer, that is going to be transferred in the form of the frame to the data link layer. So, at the sender side, suppose if this is the sender, this is the receiver, right? This is the sender, this one is the receiver. How exactly the frames are going to be transferred between the node to node. So, here, sender side data link layer receives the packets from the network layer. At the same time, these packets are going to be divided into the small frames. At the same time, that sends to the each frame bit by bit to the physical layer. So, whatever data is coming from the packets, that is going to be transferred into the frames. These frames are going to be transferred to the physical layer, that is in the form of bit by bit to physical layer. Bit by bit, the data is going to be transferred to the physical layer. So, coming to the, at the same time, it attaches to the some special bits. The special bits are nothing but the error control and addressing. Whenever coming to the physical layer from the data link layer, that can be attached to the special bits like error control and addressing to the header of the end of the frame. At the same time, coming to the receiver end now. So, in this receiver end, this data link layer takes the bits from the physical layer. So, this is the physical layer. It takes the bits from the physical layer from the receiver side, and afterwards it organizes them into the frame from the physical layer. So, here also receiver side also physical layer is there, right? This physical layer, whatever frames are coming from this physical layer of these two, this physical layer, this is the sender and receiver, right? So, there we have to transfer the frames in the form of bits here. So, from these bits again sent to the data link layer in the form of frames again. So, these can be organized into the frames and sent back to the network layer. Whatever frames are coming from here, that is again sent to the network layer in the form of the packets, that is the receiver side. So, it is mainly having the 4 fields. Those are nothing but the frame headers. So, it is having the header, at the same time payload field is there, and at the same time trailer is there. It is a trailer. And here flag is there, right? Before frame, starting and ending, we are going to add the flag. Here we have to add the flag. Starting and ending of the frame, we have to add the flag. So, it is the beginning and ending of the frame. It tells whatever flag we are adding, right? It tells that this is the beginning and this is the ending of the frame. That is about the flag. And coming to the header, what is header here? It contains the source and destination address of the frame. Suppose this is the frame, this is the total frame. This frame is telling that this is the starting and this is the ending. So this is the starting of the frame, this is the ending of the frame. And coming to the header, it is saying the source address as well as the destination address. Source and destination address. What is the source address? Which device I have to send the data? What is the exact address? What is the source address? Those are comes under the header. And coming to the payload field, what exactly it is saying? It contains a message to be delivered. Whatever data is coming from the network layer, that is in the form of packets, those exact informations comes to the payload field. That is nothing but the payload field means exact data. Whatever data is coming from the data link network layer, that is transferred to the data link layer. That is the exact data. And coming to the trailer, it is having the error detection and error correction. Means if any errors are occurred in between transferring the data, there we are going to use the trailer for detecting and correcting the errors. That is the frame. Flag is for what? Flag is for beginning and ending of the frame. Header is containing the source and destination address. Payload field means what exactly data is received from the network layer, and trailer is talking about the error detection and controller. Same from receiver side also, same flag is there, and it is also having the header, payload field and trailer from the receiver side also. This is about the framing. And coming to the next design issues is that is addressing. What is addressing here? Addressing is nothing but the data link layer that encapsulates the source and destination MAC address. Means it is saying about the address of the source as well as the address of the destination. What is the exact address of the source? What is the exact address of the destination? That is the MAC address. Exactly which device I have to send the data. See in this picture, here 4 devices are there. Each device is having their own MAC address. How the MAC address is given? It is the unique hardware address. MAC address is nothing but the media access control address. This is the unique hardware address. It is assigned. When it is going to be assigned? When the device is going to be manufactured, that time only this MAC address is assigned to this particular device. That is nothing but the MAC address. That means exactly which device, means based on that we are going to send the data by node to node delivery from one node to this is one node and this is another node. These are the different types of node. Not only this desktop, laptops, whatever mobile phones, all are comes under the devices, means nodes only. So each device is having their own specific MAC address. Based on that only we are going to send the data to node delivery. That is about the addressing. And coming to error control. What is error control? Whatever data is sending from the network layer to the data link layer, the data maybe can get corrupted. Various reasons like noise is there, attenuation is there. Based on for such particular reasons that data may be corrupted. So it is the responsibility of the data link layer for error control. Means first whatever data is there, that you have to detect where exactly error is there. To detect the error that is transmitted and correct those particular error using the error detection and correction methods. For detecting where exactly error is there, we are going to use error detection methods. There are different types of the methods are there in error detection, as well as the after detecting the error, we have to correct the error. Where exactly error is there, based on that you have to correct the error using some particular methods for error correction also. This data link layer adds the error detection bits into the frame header. Whatever error detection is there, errors are there, that are going to be added to the frame header so that the receiver can check the receiver data is correct or not. That is the data link layer error control. And it adds the reliability. When there is no errors, it contains as a reliable data. So that reliability to the physical layer means it will detect the error and it will correct the error. That's why it adds the reliability to the physical layer by adding the mechanisms to detect and retransmit the damaged or lost frames. Whatever frames are lost or damaged frames, those are also corrected here. That is nothing but error control. It is having the error detection and error correction. This is the one of the design issue of the data link layer. And coming to the next design issue is the flow control. What is flow control? Suppose here is the sender. Here is sender and here is the receiver. When the data is sending from the sender to the receiver, the capacity, suppose for 1 minute, this particular can send the 10 frames. In 1 minute, it will send the 10 frames. Coming to the receiver, for 1 minute, it will receive only 2 frames. For every minute, it will send 10 frames. For every minute, it will receive only 2 frames. Again, next minute, again it will send 10 frames. But the receiver is receiving only 2 frames. So, there may be chance to the collision because the data may be lost because the sender capacity is different here, the receiver capacity is different here. That is nothing but the flow control. How the data flow is going in between the sender and receiver. That is talking about the flow control. How we can manage the flow control. That is the data link layer main aim. So, here the receiver is receiving the speed is slower than the sender sending the speed. So, here the receiver speed is slow compared to the sender speed. It is very fast and it is slow, right? Here it is sending for 1 minute, it is sending 10 frames. For 1 minute, it is receiving only 2 frames, right? The sender capacity here is fast, here is slow, right? Then it can lead to the overflow of the data. So, receiver buffer and some frames may be get lost because for every again next minute, again it is sending the 10 frames. So, it may be lost of the data. There may be chance to get the lost of the data. So, that reason we have to follow the flow control mechanisms. That flow control mechanisms also we will discuss in next classes. So, here the responsibility of the data link layer is nothing but to synchronize the senders and receiver speed. Means we have to follow, we have to control the sender speed and receiver speed. At what speed the sender is sending, at what speed receiver is receiving. That we have to check in the data link layer and establish the flow control between the both sender and receiver. That is nothing but the flow control. And next the design issue is the access control. What is access control? When the multiple devices, different devices are there like laptop, desktop, mobile phone, all are the different devices share the same communication channel. There may be chance of high probability of the collision. Suppose access control mainly talking about when the sender is there, here the receiver is there. This is the channel for sending the data. Suppose here number of devices wants to send the data using this particular channel only. All devices, these are the different devices, all wants to send the data using this particular channel only. If number of devices, multiple devices want to share the same communication channel, so then there is a probability of the collision. There may be chance to occur the collision. That is nothing but the access control. So, the responsibility of the data link layer is nothing but to check the which device has to control over the channel. Which device I have to give the first preference to send the data using the some mechanism. Those are the CSMA by CD. That is nothing but the carry sense multiple axis, collision detection, carry sense multiple axis, collision avoidance. These are the methods for using the for reducing the collision to avoid the collisions and loss of the frames in the channel. That is the main aim of the access control. Whenever we are using this particular channel to avoid the collision, we are going to using channel allocation some methods. Those are CSMA by CD, CSMA by CA, collision sense multiple axis, collision avoidance. These are the different methods can be used for reducing the collision. This is considered as a access control. This is the one of the design issue of the data link layer. And coming to the today's summary, today we discussed what is data link layer. Data link layer is mainly talking about what? Node to node delivery and error-free transmission of the data. And coming to the what are the different types of the data link layer, what we discussed, right? What are the different types of the data link layer? What? That are the LLC, logical link control, and the MAC layer. These are the two types of the data link layer. And design issues. What are the design issues we discussed today? So those are the flow control, error control, access control. These all we discussed in today's topic as a design issues in the data link layer. Thank you.